Hydrate Practice Part 3. If Epsom salt, MgSO4, plus some number of water molecules, is heated to 250 degrees Celsius, all the water of hydration is lost. On heating a 1.687 gram sample of the hydrate, 0.824 grams of MgSO4 remains. What is the formula of Epsom salt? Alright, so a number of pieces of information have been given to us. The first one being this one right here, 1.687 grams sample of the hydrate. This is the sample that contains the water. The number 0.824 grams of MgSO4 remains is just the mass of the anhydrate. Let's write those numbers down. So we have the hydrate sample, and that is 1.687 grams. And we have the anhydrate sample, and that is 0.824 grams. And what we need to do here is subtract the two. And when we subtract the two, we find that the difference is 0.863 grams. So the hydrate sample has the water. The anhydrous sample does not have the water. The water's been removed. So that means this amount right here, the 0.863 grams, represents our amount of water. Now there's two key pieces of information that we must have before we can go on. One is the mass of the anhydrous sample right here, and the other is the mass of the water right here. Once we have these two pieces of information, the next thing that we're going to do is convert the sample of the mass of water into moles. 0.863 grams of water. We know that the gram formula mass of water is 18, so 18 grams of H2O. 1 mole of water will go on top. And the next thing that we have to do is check our units. So grams cancel grams. So when we do this calculation here, 0.863 times 1 divided by 18, our answer will be 0.0479 moles of water. The next thing that I want to do is take the mass of my anhydrous sample, 0.824 grams of MgSO4. And like I did above, I'm going to convert this into moles. 1 mole of MgSO4 has a gram formula mass of around 120 grams of MgSO4. So again, we're going to cancel our units. Grams cancels grams. And when we get an answer here, we get roughly 0.0068 moles of MgSO4. The next step is to take the moles of the water and divide it by the moles of the anhydrous salt, which in this case is MgSO4. And when you do these types of problems, typically we're looking for a whole number. So your larger number will go on top and the smaller number will go on the bottom. So our moles of H2O here is 0.0479 moles of water. We're going to divide that by 0.0068 moles of our salt. Just write salt here. And when we do that, we find that this number works out to be 7. When we rewrite this formula right here for the hydrate, it is MgSO4 dot 7H2O. And that is how we represent Epsom salt.